Hi class, it's Bill Berry here with an introduction to working with data, understanding more about data types, and then looking at the conversion that SQL can do for you implicitly or explicitly. So we've got a lot to cover here. We'll do it in a couple of different videos so that they won't get too long as usual. And so let's get started with that. And the first thing we're going to do is talk about sort of the groundwork that we need to do to talk about some background things that you need to know about and remind ourselves of before we get going. One thing to note, some terms that you want to familiarize yourself with. First is DML, Data Manipulation Language. So far, everything we've done in the course regarding working with queries is all part of data manipulation language, and tonight is no different. So we're still working with data manipulation language. That has to do with data, right? So querying the data, adding the data, editing the data, removing data, all about data. But soon we're going to turn the corner and we're going to start working with data definition language, right? So DDL. Data definition language is about definitions, which means schema. We're modifying the definitions. So how do you create a database from scratch? How do you create tables? How do you set the definitions, the data types and things for the columns? So we're moving into that soon, so you should know those two terms, DML and DDL. So first we'll lay some groundwork, as I said, then we're going to work with the different types of data that we're going to work with, right? Adding, editing, and removing data. And then we will move on to part two, talking about SQL's data types. These are not exactly the same as they are in programming languages. There are some weird differences, so we want to understand that, and then we're going to do the conversions. So that's our goal. Again, several videos. One thing to note is that in this video there won't be practices per se. There's some examples, but we'll save the practices for doing in class together. But at least this should sort of get you going and give you the basic understanding. So in terms of the groundwork, there are some really important things that we need to go over. One we've talked about before, and second one is something that you won't have maybe encountered, so we need to talk about that and differentiate it. The first key term here is called referential integrity. Referential integrity says that your database system, your database software needs to make sure that your data is in sync, that your data has integrity, which means it doesn't have anything that would prevent you from trusting it, that everything in your database works together in the proper way. There's nothing that keeps it inconsistent, that makes it out of sync, that everything is kept together in a way that you can trust it, right? This is something that is a linchpin for database software. If your relational database software doesn't help you guarantee referential integrity, that's a problem, right? So if we set things up correctly, then SQL will make sure that our data stays in integrity. But what does integrity really mean? Well, the key thing is, remember, everything works with keys in this world. So the idea is every foreign key should refer to a valid existing primary key. Right? So there shouldn't be any orphans, right? So that's the main idea of this referential integrity thing, no orphans, right? So if you have a primary key, great. If you have a foreign key, it has to refer to a valid one. So there are several implications and things that are underneath that the database system will help you with. So one is, of course, you don't want to have duplicate primary keys, right? You expect it to reject any duplications there. Great. Well, that one sort of makes sense. But here we get into foreign keys. So here's one. You can't enter data in a child table that isn't matched with the primary key in the parent table, if you want to call it that way. You can't add something on the many side that isn't matched with something valid on the one side. You also can't delete a primary key if there are foreign key children in some other table. Oh yeah, I guess that sort of makes sense, doesn't it? You also can't edit a primary key and change its data so that you then have a mismatch with the foreign key children. So that's important as well. One thing to note is that modern versions of relational software, relational databases, the way that it does referential integrity tends to be with something that's called declarative referential integrity, right? That means that the referential integrity is actually declared or built into the structure of how we set up the schema or the design of the database. So when we get to where we're creating databases, you'll see that you can actually declare this part. There'll be part of the syntax that says, here's how you create referential integrity between these two tables. So that's all part of the schema. So all important stuff, and a lot of things will make sense. Like some things that we've seen from the very beginning, like it doesn't matter whether the column names match between the primary key and the foreign key in the separate table. Well, how is that? Why is it that you can misname them? It seems like an error. Well, it's not, because you're declaring. You're actually going to say this thing matches with that other thing. So that's all part of referential integrity. Okay, so pause the video if you need to, and think about that, or run back and listen to that again. We're moving on to another topic, but you need to know that that topic is different from this one. So moving on. The next thing that we want to understand is that MySQL is downloadable and usable by end users, right? It is server software, but still it's free, and you can download it and run it on your laptop or on your desktop computer at home. Well, that's great. But if beginners are at the helm, as we are, because when we're running MySQL, in essence, we are the admin, right? We have the root password. That means it's easy for us to make a huge mess of data. As we'll see with several of these commands, the default is that the commands will affect every row in the database, in the table that we're working with. That means if you had 1,000,000 rows of data, with one command, you could either do something good or do something bad to all 1,000,000 rows. That's a pretty heavy burden. So because MySQL realizes that there may be beginners at the helm, there are beginners who have the root password here, any kinds of destructive commands, MySQL provides something that I would think of as training wheels to make it less likely that you use this sort of weapons of mass destruction in the commands that we're going to learn about today. Those training wheels are called safe update mode. Right? Safe update mode says, hey, I know that you're new at this, you're very likely to make a mess, so I'm going to put on the training wheels so that you have to be a little more specific. Right? You have to be more specific by using primary keys to make sure that you know what you're talking about, that you pinpoint the data that you're going to change, right? So you have to narrow it down. Don't just issue commands that wreak havoc in the whole table. Narrow it down. Tell me exactly what primary key you're talking about. That way I know that you know what you're talking about, you're focused, and then I will do the command. So by default, MySQL will simply reject any commands that cause problems in this regard, where you haven't paid attention to using the primary keys. You can turn that off later, but for the purposes of the class, you shouldn't, right? You should understand what's going on and why it's doing this stuff for you. Now, if you are paying attention, you'll see this is not the same as referential integrity, right? This is not at all the same thing. This is training wheels to keep data editing commands from destroying a lot of valid data, whereas referential integrity has to do with primary keys, foreign key relationships. So don't confuse these two things, and so as we're working through, we'll see the need to do this, and hopefully it will all make sense as we go. So again, pause here if you want to go back and you want to refresh yourself on the difference between referential integrity and safe update mode. All right, so now we're going to go back and look at syntax. We've given you syntax descriptions or syntax diagrams. I guess descriptions are a proper term. We've talked about these a bit, but we're going to get into syntax that is more deep and more intricate. So we want to make sure that we know all of the syntax description conventions. So let's go look at those, and then we'll probably break the video at that point, and then we'll start into the actual data commands. So let's jump into that. So if you see in a syntax description, remember that syntax descriptions are not sample commands at all. They're not samples. They tell you how to create the syntax, how to write your commands by trying to describe different things that are going on. So for instance, if anywhere you see things in uppercase in a syntax description, it means, oh yeah, you should type those exactly as it is shown. So if you see the word insert, capital I-N-S-E-R-T, it means don't get creative with your spelling. Remember that SQL is not case sensitive, so you could type this in any case, but when you see it in uppercase in a syntax description, it means be careful with your spelling. Type I-N-S-E-R-T. All right? If you see things in lowercase, it means you're supposed to fill in the blank with something that makes sense in your context. So for instance, if you were looking at the syntax description of the where clause, it would say where and then condition. That means you're going to type W-H-E-R-E, and then after that you're going to supply something that is a valid condition. Now, it doesn't mean you type C-O-N-D-I-T-I-O-N, right? That's not the point. Don't type that. Supply a condition that makes sense, right? So once you understand that, you go, oh yeah, a condition is something like cust name, cust last name equals Smith. Great, that's a condition, right? So I'm going to substitute that there. All right. Now, also we've seen square brackets, and that means that the piece that is shown in the square brackets is optional, right? So that means use that piece if you need it, or sometimes it's just completely optional. Use it if you like to see the word. So here, for instance, with insert, you can say insert and then square brackets into table name. In this case, whether you use this word or not is completely optional, and it doesn't affect the command at all. So you can say insert customers or insert into customers, and it's fine either way. So when you see things in square brackets, they're optional. Again, don't type the square brackets, right? Square brackets are never valid SQL, right? So don't type those things in. This is just describing to you the situation, the different ways that you can use the syntax, the command that you're talking about. Okay, so now for some new stuff. When you see a vertical bar means you have an option, right? That means you can pick one thing or the other, whichever thing you need based on your context. So here it's optionally either ASC, ascending, or DESC, descending, right? And of course the whole thing's in square brackets, which means the whole thing's optional, all right? So that's one convention that you're going to see. Vertical bar means you have a choice. Now, sometimes you will see them in curly braces, right? And again, curly braces are an artifact of description language. They're not something you would type, but when you see these, that generally means you must choose one of these. It's not that the whole thing's optional, it's that you gotta choose one. So for instance, in order by, you either need to put the column name or some other expression, or you need to put a position, but you gotta choose one of those, right? You can't just say order by and leave it out. So that's what vertical bars mean. Now, if you see ellipses, right, dot, 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 that means that you can continue to do a similar pattern as you go forward. So for instance, if it says expression 1, then optionally, if you would like, you can put a comma and then another expression and then dot, dot, dot. That means you're not limited to 2 expressions just because 2 are shown here. You could do more, right? You could put a comma and a third and a fourth and a fifth. You keep putting commas and more expressions. So follow the pattern, keep going, blah, blah, blah. Then if you see anything else that's not specifically listed here, right, on these 2 pages we've covered uppercase, lowercase, square brackets, vertical bars, ellipses. Anything else you need to take literally. So for instance, if you were to see parentheses, expression 1, comma, expression 2, dot, 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 but it's all in parentheses, that means you have to type the parentheses. These are not a notational artifact of a syntax description. They are required by the command, right? So that's all fairly typical syntax descriptions, and in fact some of these conventions you'll see when you look at syntax descriptions for other languages too. If you're studying Python, Java, they may be expressed in a very similar way. So let's look at a sample and see if we can decode all of that stuff, right? First thing you can see is the select command is here, and then if you look, everything else is in square brackets, which means nothing else is going to be required except the select expression, right? This is the only thing that is not in square brackets. So that's the only piece that's required. Now what can come before that? Well, you can say distinct, or you can say all, or because it's all in square brackets, you can say neither. So that's a new piece of information for us, right? So if you keep looking down, you can follow those things and see that all of this is part of the syntax of the select command. And if you know that, you can write commands pretty effectively. You can get the syntax right a lot of the time by following the syntax description. Hopefully that helps. All right, so we're going to stop the video here because we've already been going almost 14.5 minutes. So let's stop here, and then in the next video we're going to pick up this idea of working with data. How do I add data to a table, change the data that's there, and remove rows from the table? So we'll learn all of that in our next video. But for the moment, let's pause, and thanks for watching this video.